Question 6, sorry. Figure 16 shows a boy of mass M standing on a platform about to perform a bungee jump. He steps off the platform and falls vertically. The tension in the rope increases as it stretches. The boy accelerates to rest at the lowest point of the jump. Lowest point means closest to the ground. Okay. During the jump, S is the vertical displacement moved by the boy's center of mass. The lowest point of the jump occurs when S is 27 meters. Figure 17 shows the variation of his velocity V with S during the jump. Okay. The boy experiences free fall when he steps off the platform. During which part of the jump does the boy's acceleration begin to decrease? Okay. Okay. So in this question, you can see that the value of the gradient is decreasing, right? So when gradient is decreasing, it means the acceleration is decreasing. Here the gradient is more, right? And here the gradient is less. So less gradient means less acceleration or decreased acceleration, right? So therefore, we will say that the acceleration is going to be decreased from 7.5 to 15 because of the low gradient. As gradient from 7.5 to 15 is decreasing. So we will say that the acceleration is decreasing from 7.5 to 15. Okay. From 7.5 to 15 meters. So that is the answer. When the boy's center of mass has moved through a distance of 15 meters, the change in his gravitational potential energy is 9.56. Calculate the mass m of the boy, sorry. It's very simple. GPE is mgh, right? So GPE is 9560 joules, and the mass of the boy has to be calculated 9.8, and h is 15. So from here, mass of the boy turned out to be 65 kg. The bungee rope has a stiffness of 110 Newton meter and obeys Hooke's law. The maximum kinetic energy of the boy is 7.71 kg. Calculate by considering the energy transfers the extension delta of the bungee rope when kinetic energy of the boy is at maximum. Okay, so what was the maximum potential energy? Maximum GPE was 9560 joules, right? So when GP is maximum, KE is 0. It means so total energy is actually also 9560. Okay. Now out of this total energy, which is 9.9560, 7.71 kilojoule has been turned into kinetic energy. Okay. So kinetic energy is gone as 7710 joules. So remaining kinetic energy in rho, or remaining energy in rho, that will cause extension. Okay. Will be equals to what? So extension kinetic energy will write extension KE. Okay. We will write extension KE equals GPE minus kinetic energy. So that will be 9560 minus 7710 equals how much of the energy? That is equals to 1850. 1850 joule. Now this is the energy that will cause extension in the string. Okay. So I will simply write E equals half F delta X, but I don't know F. So I will put F as A delta X and delta X. Okay. So E equals half A delta X squared. This is the energy that will be used as extension. 1850 times 2 equals K. K is 110 into delta X extension. So upon simplifying, the answer is going to be 5.8 meters. Okay. That was 6.3 and now 6.4. Deduce the tension in the rope when the kinetic energy of the buoy is at a maximum. Give a reason to support your answer. Okay. Okay. So when, for example, this is the buoy coming down and consider it as a mass, okay? So that tension force is actually extension force, right? Extension force. That extension or that tension is actually causing the extension, right? So I will just write the tension in the string is actually the force which will cause the extension. Okay. Therefore, we will just write F equals K delta X and F will be equals to T. We already have 110 and we already have extension, which was 5.8. So the answer to the tension is 638 newtons. And that is actually the reason for my answer. Okay. The original rope is replaced with a second rope and the boy repeats the jump. Table 1 contains information about the original rope and the second rope. Both ropes obey Hooke's law. Table 1 shows you original rope data and second rope data, and they have given you the formula to calculate the Young modulus. Okay. Show that each rope has same stiffness. So it's very simple. Just use this formula for all rope. Okay. So Y is equals to E, stiffness is equals to K, and stretch length is L, cross-sectional area is A, so K is actually equals to AE over L. Now again for new, this is for old, and this is for second. Okay, my apologies. Now all you need to do is just to find out the original rope for first. We need to find the stiffness and show that the both ropes have the same stiffness. So first of all, we will write original rope. And for original rope, Young modulus value is E. Stiffness is K. Unstretched length is L for original rope. I'm just giving out the data. Okay. And cross-sectional area is A. So K's value is AE over L. Now for second rope. For second rope, Young modulus value is 1.2 E. Stiffness is K. Unstretched length is 1.2 L over cross-sectional area is A. So K is going to be equals to 1.2 cancel with 1.2 AE over K. So same stiffness. AE over L. Okay. So same stiffness. We have proved it. So now I think this is the last part of the exam. Deduce whether boy's maximum velocity is increased when using the second rope. Oh, important question. See, initial consider that the first rope was L and the second rope was 1.2 L, right? Right. So it means that if this is 100, it is 120. So it means 20 meter more. So if you fall 20 meter more, it means you will gain more speed because you're falling freely, right? So first of all, we are going to write that The second rope has greater length than the first rope. Therefore, the body will stretch, not stretch, the body will be freely falling for greater distance, okay, and greater time. And when it will be falling for greater distance, greater time, that means it will gain more speed. And when it will gain more speed, Ke will be more as well. As kinetic energy is half mv square, which is directly proportional to speed. Okay, that is the end of your exam. Thank you very much for giving me the time and seeing my walkthrough. Wish you all the best for your exams. If you need any help in physics, do let me know in the comment section or in my email or on my WhatsApp. You can contact me for personal tutoring. I will be always here to offer my services. Okay, up till next video, it's goodbye. Thank you.